Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Private Limited. I have 14 years of work experience in the fields of artificial intelligence, software development, and robotics. In this session, we will be creating image classification project using TensorFlow. Let's start. This week, we will be looking at CNNs, how they work, and one project, image classification using CIFAR10 dataset. So I will show you first the output, how it looks like. So this is the image classification problem. We have some images and we have to classify the objects or animals it contains. So this is the problem. So we need to detect the objects as well as animals in the images that we have. So I have created the article, new article in the blog section, Introduction to CNNs. I will tell you some basics what CNNs are, and in this project that I have shown you the output we will detect. Okay, so I will show you step by step how this training works and how this model works. We will train the model and see the output. You already know that these solutions are being used in the market. So if I search for example, frog, so we will get images of frogs only in Google Images. So nobody is manually checking these things in the backend. They have millions of images available. So how are they automating these things? So they are using machine learning models to detect the objects or animals or any other thing in the images and then categorizing them and adding the metadata to it. So they are automating these things using these kind of machine learning models. And for this problem, image or object detection problem, we are using CNNs, convolutional layers, pooling layers, fully connected layers. I will tell you what these layer means and how they work. So let's see how it is done. And in the previous sessions, in I think in this one, I told you different terms, technical terms related with the TensorFlow and neural networks. So these four terms that I told you. So we are working on CNNs now. There are many models already available in the market for detection, but if you want to train your own, then this is the process. And in the industry, mostly what companies will want is custom models and not the pre-trained models, because pre-trained models, as you know, are of 5 GB, 10 GB or more than that. If you want to detect only different type of horses, if you want to detect only different types of mobiles, then you will require to train a custom machine learning model. Let's see some basics. So this is a class of deep learning algorithms primarily used for processing structured grid data such as images. So mostly this algorithm mostly used for images. Unlike traditional neural networks, CNNs take advantage of the hierarchy pattern in data to capture spatial temporal dependency efficiently, where it is used for image recognition, video analysis, medical image processing, natural language processing. So in all these fields this is being used. So what are the key components? What are the key components and these terms? I tried to add some very easy examples at first. So let's see. Convolutional layers. Think of this layer as a magnifying glass that looks at small parts of a picture. Instead of trying to see the whole image at once, it looks at tiny pieces one at a time, like 3 by 3 square. So simple, in a simple manner, you already know about magnifying glass. So what it did is it will magnify some area, particular area that is important. So this is what this layer is. Imagine it as a magnifying glass that looks at small parts of the picture. Instead of trying to see the whole image at once, it look at tiny pieces one at a time. The magnifying glass focuses on pattern like edges. So what it magnifies is, so it will try to look at patterns like edges, shapes, colors, corners, lines, textures in picture. You don't have to do anything manually. Filters, these are called filters and they are already available in the algorithm. So they help the network see different parts of the image more clearly. So this is the first technical thing. Second, layers are pooling layers. Okay, so you got the idea about whole image to look at the small parts of the picture. Then goes what will happen after this. So this is what will happen. Pooling layers. After the magnifying glass finds important patterns, the pooling layer comes in like a simplifier. It reduces the size of the image by picking out the most important details. It reduces the size of the image by picking out the most important details. Imagine you are looking at a group of 4 tiles and you only keep the biggest or most noticeable one. Then part come with the fully connected layer. What it means is, fully connected layers work like decision making part of the brain. After these layers have figured out the important patterns, the fully connected layer takes all this information and tries to understand what it means. It connects every detail from the previous layers and tries to guess what the image is. So like dog or a cat or a tree, it's like taking all the clues and putting them together to make the final decision. So uh, for decision making process comes the fully connected layers. So you will be, if you look for CNNs, then you will find these technical terms. Remember these technical terms. Whenever someone is saying these terms, this is what they mean. Okay, so this was the example, very basic example that I created to tell you about the layers. Then comes the part how technically we understand the thing. So these layers are the core building blocks of CNN. Instead of connecting each input to each neuron as in fully connected layers, so if I search for fully connected layers, if you remember in previous sessions, each node is connected with the next node like this, fully connected. So CNN use kernel or filter that slide over to the input image. So it contains kernels or filters that can come on top of the input image, and each filter is a small matrix that is applied across the image to capture different features. So each filter contains some different type of so detect some different feature. For example, a filter can look for the edges, filter can look at the textures, filter can look at other patterns. So there are different features available and they will look for different filters will look for different features. So they are already available, we just have to use them, but the concept is this is what will happen in these layers. The process of applying a filter to an input image is called convolution. So this is what the term is and this is what this layer is. So this is the simple definition: the process of applying a filter to an input image. So this is the definition, simple definition if someone asks you. So as the filter slides across the input, it computes a dot product between the filter and the local region of the input image, creating a feature map. Multiple filters, so this is important, multiple filters are used to capture different features from the image. So you cannot just apply one single algorithm and detect everything. There are multiple filters available. Some will look for edges, some look for texture, some for other patterns like this, and this is what this layer is all about. Now what will happen after this? Pooling layers are used to downsample the feature maps. Pooling reduces the spatial dimension, width and height of the feature map, making the network more computationally efficient and robust to small translation in the input. So after this process, size of the computation will be large. As you understand, size, we will be dealing with a large amount of data, so it is important to reduce the complexity and data so that we can compute it easily. So this is where pooling layers will come. Most important type or most common type of pooling is max pooling, that I told you earlier in the example also, which selects the maximum value from the patch of the feature map. And I told you in a simple words, if you remember here, to keep the biggest or most noticeable one and removing other things. And in these technical terms, which selects the maximum value from a patch of the feature map. Other types include average pooling, which computes the average value over a patch. So for example, in a 2x2 max pooling layer, the feature map would be divided into 2x2 regions and the maximum value for each region would be selected to form a smaller feature map. So smaller feature map, as I told you, edges and different kind of things. So you will find these kind of definitions everywhere on the internet, but don't get confused. In simple words, I have mentioned everything. This is what happens in the backend. Then comes the fully connected layers. Fully connected layers, they are also known as dense layers in Keras. Dense layers in Keras are typically placed at the end of CNN architecture. These layers are responsible for combining all the extracted features to make final prediction. Remember these words: final predictions. Final predictions. In a fully connected layer, every neuron in the previous layer is connected to every neuron in the current layer. Look at this. Every neuron in the previous layer is connected to every neuron in the current layer. Same as the traditional neural network. Same as the traditional neural network. These layers allowed the model to make final decisions. So when you go for final decisions, then you will require fully connected layers. So these are the important terminology you will be looking at again and again for CNNs. I will continue this session in next video. See you in next video. Have a nice day.